Hi everyone, this is the video demo of the DjWebdApp Django app. DjWebdApp is a Django app to work with the blockchain. It includes different utilities which you can use together or separately, including blockchain indexer, private key vault with Fairnet encryption, blockchain writer, and blockchain data normalization. MetaMask authentication backend. This is still to add. We don't have it, but we have the rest. Multiple blockchain support, Tezos and Ethereum. This demo is going to be the demo for Tezos. And inter-blockchain contract synchronization. This is, of course, possible with the Django. So to get started, we're going to start with the demo project. Let's start by cloning it. And then enter the directory. We're going to create a variable env so that we start with a fresh environment. And I'm going to install repository using the all extra requirements. I'm not using the binary extra requirements. This is for installation of C modules for Python that I prefer to install using the system package manager, but you could also install them with pip. And we are currently using the deprecated legacy resolver until one of our dependencies, DjWebdApp, updates their own dependencies. And we now have the repository and the requirements installed. So we're going to run the database migrations for the demo project and start a shell with the Django environment loaded. And we also going to need to start some local blockchains. So to make it easier to have code portable from tests and local, we're adding a few hosts on etc hosts, and we can then start with the docker compose up command a few blockchains. We are going to have Tezos and Ethereum blockchain. We even have local tzkt API, which is not mandatory, which is not necessary, but we do have features to integrate this, so they're also tested, so that's why we have everything. So now let's go with the Tezos tutorial. So we're going to work with this sample contract. It's not a real FA12. Obviously you can see there's like just a little code, so it's barely enough so that we can go through testing the different features. It's already compiled, but if you want to compile it, you can just go in the example Tezos repository and compile it with the PyMish compiler. So let's first get Tezos blockchain client. We're going to use PyTezos as a client, but you could use any client. So there we go. We have a client using one of the sandbox accounts. The sandbox accounts are hard-coded in the Tezos init script. We can check our balance. And we're pretty rich. So let's deploy a smart contract. For that, we're going to first load the source code, which is Michelin JSON, right there, and create an initial storage to deploy this contract. Now, using the PyTezos client, we're going to originate a contract, which will return an operation group. And now we're going to get the contract address from the operation group and call the mint function of our contract. So we get like 1,000 of these new tokens, which returns an operation group, because that's how the Python client works. Now, for as far as DjWebdApp is concerned, we're going to have create a blockchain with a provider class. For Tezos, this is the provider class, and add a node to query on that blockchain, which is our local node. Now we're going to want to index a contract. To index a contract, first we import the Tezos transaction model, and we are going to create a contract on that blockchain with that contract address. Okay, that's going to insert it in the database. There's nothing more. Some variables have been already set. The machine was downloaded, for example. This contract doesn't have yet any calls in the database because we haven't indexed it yet. So let's index that blockchain. And now, as you can see, we have a call. We have a call with the min function and the args that we specified. So that's already how easy it was to index contract. Of course, you can use also commands, manage.py commands to index the blockchain. We're using the Python API now because you'll see later on that's pretty useful if you want to create a bot and orchestrate some blockchain calls. So now we're going to talk about normalizing incoming data. So to normalize the data, we're creating a FA12 contract with the relation to Tezos transaction. So when we want that, when we have a Tezos transaction that we have indexed and that has an FA12, we want a FA12 model. In this model, we added relations to both transaction classes for Ethereum and Tezos because further on in the tutorial, we'll learn how to mirror contract calls from a blockchain to another. But for the moment, we are going to focus on Tezos. And we are creating also a mint model in the database, which has a foreign key to FA12, the FA12 model that we have above, and another relation to the Tezos transaction model, so that every mint call, like this one. You see, the call is a Tezos transaction with the mint function, and we want an actual mint model to be created for each of these, so that we can normalize the mint calls. And so this has a foreign key to the account model and a value. We're also creating a balance model with relation to FA12 and a balance integer for each address for a given FA12. Now we're going also to create a function which recalculates the balance for an FA12 contract given an address. We're not going to just decrement the balance fields because on the blockchain we may face a reorg. A reorg means that some transaction will be invalidated, so we always want to completely recalculate. This is plain Django Python code. There's nothing special about that. Nor is there anything special about this code. If you've been through the Django tutorial, you probably know what it's about already. And we are going to use a couple of signals, connect to a couple of signals that Django emits when we save a model. So this is also plain Django code. We have, let's say the first one is to, whenever a Tezos transaction is saved by the indexer, if it has the mint function, and if it has an FA12 contract, we want to get the account corresponding to the destination address and update or create a mint object with that call with parsed beneficiary and value. And after that, every time we create a mint, we want to recalculate the balance of the beneficiary. Now, in our case, we've deployed the contract, we've called the mint function, and then we've indexed the contract, which created another Tezos transaction for the mint call. So we also have another signal connected, the pass-save signal for the FA12, so that whenever you create an FA12 that has a Tezos contract, resave every call of the contract, which will trigger that signal, which will make sure that there is a mint object and recalculate the balance every time. So now let's use this code. We're importing our FA12 model, creating an FA12 with a relation to our model, which has call this callback, which because of this has called that one. And now we have also reverse relations by Django. We have mint object that was created. As you see, the mint call we created, the mint function that we called on the blockchain is now a mint object in the database, right? And the balance also has been updated, so that account should have a balance of 1,000 now, which is pretty nice. So that's all for the indexer part. You can use DjWebdApp just to index and normalize your incoming data. And well, then you have Django, so you get everything you can do with Django, which is like, I don't know, anything. Now let's talk about writing transactions on the blockchain through a DjWebdApp. So this is going to use, of course, the Vault feature we have. So let's import a wallet first in Tezos. That means in DjWebdApp model an account model. So let's create for this address, import that secret key, which are the hard-coded sandbox secret keys. Let's go. We have the Bootstrap account that we loaded with a balance that is a lot. Now let's create a new wallet. Create a new wallet is easy. Just create an account on the blockchain without neither an address, neither a secret key. And this will automatically generate a secret key that is Fairnet encoded. And of course, it doesn't have any balance. Let's send some coins now. Send some coins. We're going to send some coins through our own blockchain writer, which also works with the transactions model. So let's create transaction to provision 10 coin from a Bootstrap account, which we imported right there, to a new wallet, which we imported right here. Okay, so let's create that transaction. Now, this has not done anything. We need to deploy the transaction. Okay, so let's call the deploy method of the transaction, and it's deployed. We can wait one blockchain level. When transaction is deployed, it's going to set the level attributes of the transaction. So we can make the blockchain, we can wait, that means sleeping until we reach the transaction level +1. So we know we're in the next block. Let's refresh balance, because like the new wallet, that balance is still 0. We are refreshing the balance here programmatically, but you really have this command running somewhere in the cron or in a loop, the refresh balance method. So now we do have some coins on the new wallet, and which means it's going to be able to deploy a contract. Well, here we're going to use the Bootstrap account to deploy a smart contract. We have the source, Michelin source that we loaded earlier. We have a storage. So let's just create Tezos transaction model with the Michelin and storage. We're choosing a sender account. Here it's a Bootstrap, and setting the state to deploy so that the state machine knows that this contract is to deploy. And since we are testing, we don't want to try 10 times. We're also saying that this transaction should be allowed to fail twice, which means retried once before it's aborted and not taken care of by the state machine anymore. So we're creating storage. We're creating a contract in the Tezos transaction in the database. This has not written anything on the blockchain. We're also creating another transaction, which is going to call the mint function and send on the new wallet address 1,000 of these new tokens. And this still hasn't created anything on the blockchain. but those transactions are in a state that the state machine will want to deploy. So let's run the state machine once, and it found it found one transaction to deploy, and it is the contract origination. Okay, we can get the deployment level, and because now if we run the state machine again, it's not going to want to execute the mint transaction, because it doesn't know if we are in the next block or not. So let's wait for one block, and run the indexer again. And the indexer is getting like the contract address for that contract we deployed, and indexing stuff. And now we can call the spooler again, and this has deployed the mint. This has deployed the mint call. So that's it. There's maybe just one last example. There's also a repository of examples which are interesting to have in the documentation, but are really just about using Django code, and not really any code that's specific to DjWebdApp. So it's in a separate documentation. That's it for today. Hope you enjoyed. Have a great day. Bye bye.